Again. So this is the last video in our Keptn Jmeter Prometheus series. So in the last two videos we have seen how to install Keptn, and then in the second video we saw how to use Keptn to execute Jmeter load test. And in this video, which is the final one, we will see how to install Prometheus, and then how to integrate Jmeter with Prometheus, and finally automatically use Keptn to evaluate the load test. So let's get started. So the first step would be to go to terminal and install Prometheus. So in this case, we can install Prometheus in the same cluster, or we can use another cluster. In my case, I'll go ahead and install Prometheus in the same cluster where I have installed Keptn. So these same instructions, it is available in the Keptn official site. So just to show you, this is what we had done. So this is my Keptn installation and the default ones, and the job executor service, which is responsible to run the load test. So now I'll go ahead and create a new namespace called monitoring. In that namespace, I'll install Prometheus. I'll just add the repo for Prometheus. Now you see these are the new pods that's being created. Okay, get service -a. So here you see the Prometheus server, it's running as type cluster IP. So we have to change this to load balancer. After that only we should be able to access it on the browser, because with the cluster IP we cannot access it from outside the cluster. So to do that, we need to run this command. -n monitoring. So if we rerun the command, you see Prometheus server has been changed to load balancer type now. So right now this service is running on port 80, so we have to change that to 9000, because when we created the cluster we had used port 9000. So that's why to do that, what we have to is we have to use this command to edit the service. Monitoring. Okay, so let's go to the port. So you see here it's showing port 80, so that we have to change to 9000. Let's rerun service. Okay, so this has been changed to 9000. Now we should be able to access our Prometheus. Yeah, so now Prometheus is we can access. The next thing we have to do is we have to scrape the metrics from Jmeter. So to do that, so once our Prometheus is installed, we need to install the Prometheus service. So the Prometheus service is responsible to fetch the results from Prometheus server. So to do that, we'll just run this command. So this is the Prometheus service that just got installed. Now we have to tell it to point to the Prometheus server. So to do that, we'll use this command. Our Keptn namespace is Keptn Prometheus service. Our Prometheus endpoint is this one. Our Prometheus namespace is monitoring. The version that we are using is 0.9.1, 0.9.1, 0.9.1. So Prometheus service has been upgraded. So we have to run this final command, Prometheus. So basically, for which project we have to also specify those details. And our project name is demo Keptn, demo Keptn, demo Keptn, and the service that we are using is Jmeter, service Jmeter, yeah. So now Prometheus service is successfully configured for our project and this service. So which means any evaluation that you do in this project, in this service, so it will properly point to the Prometheus server. We have to tell Prometheus the JMeter job name and the port on which the matrix is available so that it can scrape it. So what we'll do is I'll just do a sample run to show few things how the matrix works. So let's go back. Get words. So this is the job that is running our load test. Okay, execute interactive minus in JS. Okay, so curl local host 8080. So you see on port 8080 we are getting the JMeter results in Prometheus format. So we have to basically find a way how to expose this matrix outside the cluster, and whatever port we expose this matrix, we have to add that port number and the job name to Prometheus configuration. And like why JMeter sends the results on port 8080 inside the cluster is because if you remember from session 2, in the job config YAML we have a parameter that we passed in the non-GUI command. We used the Prometheus port 8080, so that's the reason the Prometheus metrics from JMeter are published on port 8080. So now we have to find a way how to expose this matrix outside the cluster, and then we can access it from Prometheus. So first find a port number on which you would like the metrics to be accessed outside from outside the cluster. So in this case, let's say we find out port 9270. So 9270 is the port belonging to the host, and 8080 is the port inside the cluster, inside that pod on which JMeter matrix is available. So what we need to do is our existing cluster, we just need to publish that port. So we can do that by running this command k3d edit. Before that, just one more thing I need to show. Docker ps. So this is our cluster, and if you see there are two ports 9000 on which we are accessing Prometheus, and the other one is port 8080, that is the Keptn bridge that we are accessing. So I'm not sure what is this one. So let's go ahead and add one more port on which I can see my JMeter matrix. Okay, so now if I run the same command again, so now you see also port 9270 is now forwarding to port 8080. So that part is taken care. Now what we need to do is we need to also add 9270 for in the Prometheus configuration. Let's get configuration -a. So this is the configuration manager, k edit. Look for job. Okay, so we need to add here our, just copy this, and we'll just name this JMeter. So this 9090 is this is where the Prometheus server runs. So the Prometheus server scripts its own metrics. So by default you will see this job. So this one, and the port number that I want is 9270. I'll just correct the alignment here. Yeah, that looks fine. Let me delete the pod and got created again. Let's say refresh. So yeah, this is the new one that we have added, and the state is unknown. It's currently down. Why it's down? Because this the results are published on port 8080, which again maps to port 9270 on the host when the test is running. Because there is no test is running, so that's why you would see this down. So what we have to do is we have to run a test. Let's start a run. So let's see if our job pod is running or not. Okay, pod. So this is the pod that is running our load test. So like I showed in already, if you log into the pod and do a call on localhost port 8080, you should start seeing the metrics from JMeter in Prometheus format, which is generated by the Prometheus plugin. So our job is to access those metrics from outside the cluster. So right now we are outside the cluster, we are in the VM. We can do it in multiple ways. The easiest way is to do a port forward. So what we can do is, we know that this pod is publishing the starts on port 8080. So we can expose or do a port forward for this port onto any available port, and then we should be able to see those starts from outside the cluster. So here we are doing a port forward. We'll just replace the pod name. So now our results should be accessible from the host port 9271. So let's do 9271. Okay. Yeah. So with port forward, we saw that the JMeter starts are available externally. Now let's go back to the pod. Okay, we can stop it. So a better solution to port forward is to create a service by running the expose command. Uh, and because the port forward doesn't work properly, so what we need to do is we can create a service, and so to run it, I'll just run this command. Yeah. So in this command that you see, basically over this command over here, this basically runs this, returns this pod name, which has this alphanumeric character. I could have used the pod name directly here, but because that pod name always changes, so that's why I had to run this command. And that command is passed to the expose command, and then I'm running it on port. So the service I want to run on port 8080, and it should the target port is 8080. So what it means is it needs to send traffic to the pod which is running on 8080. In our case, it is the JMeter. So I'll just run this one. So it's a service created, k get service minus njs. So see, this new service has been created. 92. Okay. So the reason we used 8080 and 8080 here is the target port that we know is already 8080, because that is where the pod is running. And this 8080 means this is this is the port at which the service is running. So if you remember, in our we added a new port for this JMeter results using -p command, and we used 9000. We used -p 9270 and 8080 at the rate load balancer. We had used something like this. So we know that this port is the host port, the VM port, and this port is the port on which the service is running. So because we had used 8080 here, so that's why you have to give the service port also 8080 here. So now let's see if I can access the stats. So you see, I can access. I'll just run it. Yeah. So as you can see, with 9270 also, after exposing the service, I can access the JMeter stats. Now let's go back to the targets in Prometheus, and there, if I just refresh, we can see that the target is now up, which means I should be able to access the JMeter stats. JMeter count total, execute. So the command that I showed to run to expose particularly this one, what you can do is you can basically create a shell script. The shell script should always run in the background, and whenever a new load test is running, it needs to create that service so that uh, the results are available to be scraped by Prometheus. And once the load test is completed, you can delete the service. I already have a script for that. So it runs indefinitely, and there is a sleep of 10 seconds. So this basically checks if there is any existing load test or not. If not, then it kills the JES service. And if a new test that has just started, then it goes and creates the service. Basically exactly the same command. So you see, it is the same command exactly. So after setting up the integration between JMeter and Prometheus and making sure that JMeter is able to send the metrics to Prometheus, the next step is to actually put it in work. What it means is we have to trigger a load test from Keptn, and once the load test is completed, the next phase, which is the evaluation, that should trigger, and then it should automatically validate the TPS, the response time, the server side starts, let's say CPU, memory, JVM related starts, so all those things, it will automatically validate, and based on what values we expect, if the actual values do not meet those criteria, then the test will automatically fail. So that's the ultimate objective of the CI/CD based performance testing. So to get started on that one, first let's revisit the CPAD YAML file which we had used to create the project. So if you notice, so basically we had three sequences, means three kinds of tasks. One is the execution, in which we had only one task test, and in evaluation we had one task called evaluation, and then we had another one called execution and evaluation. In that we have two sequential tasks. The first is test, and once the test is completed, it will go to the next one, which is evaluation. Now, how do we trigger that one? So if you go to Keptn and click a trigger new sequence, so select our service, which is JMeter, and our here we have only one stage, so that is a load test, and here you will see uh, this sequence names. So we had execution for running the test, with the evaluation only for evaluating, and this is execution and evaluation, which is both running the load test, and once that is finished, we have to evaluate the test. So, but before we trigger that, let's understand what all things are required to make that happen. So, this is the CPAD YAML file we saw. Let's go back to our load test branch, and in load test branch, um, this is our service name. And the first thing that we have to do is we have to create a folder inside your service name called Prometheus, because that's our monitoring tool. If it is Dynatrace, then you would create a folder called Dynatrace. So after creating the folder, we have to create a file called SLI, service level indicators. So this basically contains the definition of your indicators. So what it means is, for example, the CPU says, um, this is my query. So this is the same query that you should be able to run in Prometheus. So 24% is my CPU utilization. So remember that when we installed Prometheus, so it automatically installed one component called node exporter. So what is that node exporter? That node exporter basically sends the Linux host starts basically resource utilization to the Prometheus server. So if you have a remote server, so what you need to do is you need to install node exporter. You can basically run it as a container. You can find in Google, and then it will automatically send the starts to a particular port, I think 9001, and then we can see that here it's 9100. So it sends the starts on default port 9100, and then you can scrape that metrics. uh, So here talking about the sli.yaml file, so we have the CPU usage, the memory usage, So the same query that you normally run in Prometheus, the same details you need to add here. So this is the response time. So this response time is the nothing but the Jmeter response time. So these values, the resource utilization of the host, this comes from the node exporter, and this the load test related stars, response time, average response time, TPS, the pass rate, fail rate, which I have not added, but you can do. So that comes from this the integration that we did between Jmeter and Prometheus. So if I just take this. Okay, so there is one variable called duration seconds. So what this duration seconds means is this contains the duration of the test that executed prior to this evaluation. So if we had a scheduled 30 minutes test, so this particular variable will contain 30 minutes in seconds. So that's how Prometheus automatically validates these values. Here, let me, it will not run. So what I'll do is I'll give it 1 hour here, let's say. So there are no values here. Let me give it 10 minutes and I'll just change this value. So if our test was run for 30 minutes, so that particular variable will contain here 30 minutes, and that is how it automatically works out. Um, yeah, so this is the indicator definition. The next thing that we have to do is we have to now define a SLO file. The path of the SLO file would be your project and then the service name inside the branch name, and there is a file called SLO YAML. In that, basically we have here, you can find these sample files from the official web page. So here we have given CPU usage, the pass criteria. If it is less than 80%, then it is pass, but if it is between 80 to 90, then the status of that indicator would be warning. The same is for similar for memory usage. If it is less than 30%, then it is pass. If less than 50% is warning, and if it is more than 50%, then that criteria will fail. So like that, we have defined some sample details, and here now the total score calculation. The total score calculation will be basically the number of criteria that passed. So each one will get a weightage of 1, and then it takes the average value, and if it is more than 90% or 90%, then it is pass. Between 70 to 90, it is warning, and if it scores less than 70, it will fail. So these are the two key files, the sli.yaml and slo.yaml. These are the two files we need to define. And once those files have been ready, we can go ahead and start the execution. Sure, test is running. We can go here. So this is the one that's already running. So we'll see if the target is up. The Prometheus target is up. Yeah, so the Prometheus target is up, which means it is starting to pull the metrics. Let's go ahead. Okay, so the test which I ran for 5 minutes, the test has completed, and it's showing here in yellow color. Uh, let's go ahead and click this icon here. So here we should be able to see the status. So if you see here, so this is the test that we just ran. So the overall score it shows is yellow because it scored between 70 to 90. Now you can see each the average response time status was green, CPU was red, memory was yellow, and 95th percentile response time and TPS, both those indicator status were green. If you want to see more details, okay, so here, so we had given CPU usage. If it is less than 80, then pass. If it is less than 90, then it is warning. So in our case, it's 91. So it's obviously more than the warning value. So that's why this status is failed. And so total, because I have each one has a weightage of 1 and there are total 5 criterias, so each one gets 20 points, and because this is failed, so it got 0 score here. And because this one memory usage is 44, which is between the pass and the warning range, so that's why it got a score of 10. So average response time is fine, 95th percentile response time is fine, TPS is also fine. So the total score I got is exactly 70. So that's why you see here that is the yellow color. If you want to see some more details, so what I can do here is k logs. So this guy over here, the Prometheus service, which is responsible to fetch the values from the Prometheus server. So you can check the logs. Sorry, this namespace is capital. So you see, it's generating the same queries that we had already given. So this is our query for memory usage, and it got this much value, 44% here. So this is the Prometheus service, which is using our SLI YAML file and getting those values from the Prometheus server. To verify whether the results that you are getting from this integration between Jmeter and Prometheus, and whether that is correct or not, what you could do is, so this is the test. So if you see the log here, so you will see the Jmeter test summary report here. So what you see here is the average throughput is 267. Uh, so if you go back to the evaluation result, now you see the TPS is 262, very close. So why they are not exactly same? Because the scraping interval in Prometheus that we have given is every 10 seconds. So some of the data points might be missed because of that. That's not particular to this integration, but that the general truth for Prometheus. So Prometheus uh, doesn't capture all the 100% samples that your application or your server generate. It depends on the scraping interval. So that's why what you see here seems to be accurate to me. And then if you would like to see the average response time, let's say, so if you go back here to the Jmeter log here, and you see the average response time is looks like 73 millisecond. And let's go back to the evaluation, and what we got during the test from the evaluation is the average response time is 71.66. So that's also close to what we see in the Jmeter log. So this kind of gives an confirmation that yes, the summary report from Jmeter, the TPS, the throughput, the response time details, what you get from the summary report, the same details you also get from this integration from this Prometheus server, and that's why you can rely on this QualityGate, and ultimately whatever result you get in the final output, that seems to confirm that this QualityGate through Keptn is working. So I believe that's everything in this Keptn series. If you have any queries or any doubts, or you want to get started and stuck somewhere, you can leave a message and I'll try to reply as soon as I get chance. Thank you.